Fortress. Foresight Tools for Responding to Cascading Effects in a Crisis is a project funded by the European Union's 7th Framework Programme. The project aimed at developing tools to support practitioners during emergencies, identifying cascading effects and critical infrastructures to be protected. 2 web applications have been developed within the Fortress project: the Fortress Model Builder (FMB) and the Fortress Incident Evolution Tool (FIET). Let's start seeing how the FMB works. The FMB main objective is to allow practitioners to model strategic infrastructures, called nodes, as well as the relationships occurring among them. Nodes are displayed on a georeferenced map. Let's have a deeper look. In order to access the software, an account with username and password is needed. Once the login is completed, we can create a new scenario by clicking the gear button just on the right side. Let's call it FSB, for example, and let's save it by clicking the Save button. Let's open now the Scenario Builder interface by clicking the Worker button, and let's open our scenario by pushing the Pencil button just on the right side. We have now approached the core part of the Fortress Model Builder. You will find a dashboard with 3 different frames. First, the Scenario Builder Map (SSM) on the left side, where different node typologies are listed. It can be edited on the left. Each node represents a different infrastructure we want to show in the scenario. The Scenario System Map enables the creation of specific scenarios in a very flexible way. If a child has been created, clicking on it with the mouse right button, other options can be chosen: rename, delete, associate editor, invite someone else. Second, the Relation Graph Editor on the right side, where all the nodes are represented together with the relationships occurring between them. Third, the Map Editor at the bottom, that links the nodes represented in the Graph Editor to their position in the real world, allowing the creation of a georeferenced map. The Relation Graph Editor is used to create relationships between previously added systems on the graph. Double-clicking on a specific node, a node attribute table will appear. It has to be filled with the following information: description, person in charge, list of potential hazards. By clicking on the option Create New Hazard, the following options will appear: name of the hazard, description, impact, type, recovery time, buffer time, cost. Different type of relation can be defined between nodes according to the Fortress theoretical work packages: resource relation, information relation, interference relation, jurisdictional relation, or service relation. Specific relation parameters will be requested: description, impact, and others. Accepting the relation between the nodes has been created. Let's see the Map Editor. It allows the user to create a georeferenced object, marker, polyline, polygon, circle, or rectangle, edit, delete existing georeferenced areas, associate the georeferenced feature for an already created node. Fortress Model Builder should be used to produce a scenario model. The Fortress Model Builder provides different possibilities for network analysis and criticality visualization. On the analysis criticality, the following option will appear: cascading effects potential, transmission capacity, supply potential, resource transmission capacity, information transmission capacity, information bottlenecks. Once the scenario has been created, it can be saved and downloaded as a JSON format in order to be exported on the Fortress Incident Evolution tool. Let's now have a look to the second tool. Fortress Incident Evolution tool is based on risk impact assessment of the relation between its network and graph analysis. It enables to perform a realistic emergency situation, displaying trigger elements and cascading effects during a crisis. Once logged in, the user can import and upload the scenario previously created in the FMB. The tool is separated in two main parts: Network, Map. Network. All the risks and details associated with each node can be seen. The cascading impact functionality will provide information about what and who would be affected when a crisis unfolds. By selecting a trigger element, Fortress Incident Evolution tool will show what elements are candidates to suffer cascading effects. A coloring system helps users to understand the level of criticality of each node and which elements could suffer the consequences of the trigger event. Color codes are trigger element, dark red balloon. Elements level 1, red balloons. Elements level 2, yellow balloons. Elements level 3, gray balloons. Other elements, semi-transparent gray balloon. The map allows users to create new shapes on it, allows the identification of relations between scenarios and potential risks. Scenarios created by other users can be imported or exported in this map. Map sidebars allow users to see interactive maps with different perspectives and types. The elements can be clustered on the basis of their criticality level. By clicking on the cylinder, all the elements are displayed on the screen. Fortress Incident Evolution tool provides also timeline, which gives the interactive representation of the affected events as sequences along the time. The user must select the desired crisis starting date. Then the timeline will be adjusted and will show which events are being affected at the current time. The timeline is managed by a player panel, where T simulates the progress of cascading events over time. The user can run the simulation at different speeds. Natural speed, 2 times or 5 times the natural speed. When a crisis is started, the users are able to see the progress over the time of cascading effects in real time. In addition, the timeline will display a notification to warn the user. It is relevant to highlight that past events are shown in gray, the events that are being affected at that time flash in yellow, the future events remain unchanged with their specific impact level code. To end the simulation, the Stop Crisis button must be selected. The scenario can be edited. This can be done through the following procedure. First, go on the Data drop-down menu. Second, select Simulation Manager. The list of all scenarios is now displayed. Click on the button Create Copy to Edit to modify the scenario you're interested in. A dashboard will appear requiring you to insert a new name for the scenario. A copy now has been created. In order to work on this new scenario, turn back to the Network drop-down menu and select it. On the dashboard, a new Edit button is now showed. containing two options: Add Node, Add Edge. In addition, if you click on a node or an edge, the line connecting two nodes, 4 new edit options will appear: Edit Node, Edit Edge, Edit Info, Delete Selected. With the Edit Edge option, you can move the relation from a node to another node. You can also change the information related to a specific node or edge by directly double-clicking on it. Within the same windows, you can disable a node in the network cascade by checking or unchecking the option Enable Node in the Cascade. By clicking the Graph button, you can visualize the probability and criticality of the selected node failure. The color of the indicator in the right side of the window will change with the probability: red more than 75%, orange more than 50%, yellow more than 25%, green less than 25%. Also, the timeline has a new feature, allowing you to modify the node buffer time by clicking on it and changing the node position in the global timeline. You can also perform the same operation by double-clicking on the node representation within the timeline. In the timeline, you are also able to create free events that are independent from any nodes and can be put wherever you want. To create this node, just go between the red and green lines. By double-clicking, the option Free Item will appear and a new event can be created.